Welcome back, students. This is the Q&A session 15 from the playlist of current electricity. The topic is the temperature dependence of the resistance, and based on this topic I have taken here one question which is written on this board. The question is the resistance of a wire at 20 degrees centigrade is 20 ohms and it is 60 ohms at 500 degrees centigrade. So the temperature at which its resistance is 25 ohm is. So there are four options here and we have to find the correct one. So before proceeding further, I would like to go through two important points with regards to this topic. That is the resistance or the resistivity of a metal or a conductor increases with the rise in the temperature, and its temperature coefficient, that is the temperature coefficient of resistance or the temperature coefficient of resistivity, is positive, whereas the resistivity or the resistance of the insulator, it decreases with the rise in the temperature and its temperature coefficient is negative. That is the temperature coefficient of temperature coefficient of resistivity or the temperature coefficient of this resistance, it is negative in the case of insulators. So here the question is the resistance of a wire at 20 degrees centigrade is 20 ohms and it is 60 ohms at 500 degrees centigrade, and the temperature at which its resistance is 25 ohm is. So there are four alternatives here and we have to find the correct one. So the relationship between the resistance and the temperature of any material is given by RT is equal to R naught 1 plus alpha T minus T naught, and the resistivity of the material is given by rho naught 1 plus alpha T minus T naught. Now here this RT is the resistance of the material at the temperature T, and here T naught is the reference temperature. Alpha is the temperature coefficient of resistance, and R naught is the resistance of that material at the reference temperature. And similarly, this resistivity of the material is given by this rho T is equal to rho naught 1 in bracket 1 plus alpha T minus T naught. Now here rho naught is the resistivity of the material at the reference temperature, that is T naught, and rho T is the resistivity of the material at the temperature T, and alpha is the temperature coefficient of resistivity. Now the reference temperature is normally taken as 0 degrees centigrade or 20 degrees centigrade. So here in this case I will be taking the reference temperature as 0 degrees centigrade. So if I take the reference temperature as 0 degrees centigrade, so this equation will be equal to RT will be equal to R naught 1 plus alpha T. So I will be using this equation in order to solve this question. So the in the first case the resistance of the wire is 20 ohms at 20 degrees centigrade. So the resistance at 20 degrees centigrade is 20, and this is R naught 1 plus T is 20, so this will be equal to 20 alpha. Now here in the second case the resistance is 60 ohm, and so 60 will be equal to R naught 1 plus 500 alpha, because T is equal to 500 in this case. Now from these two equations I will get means what I will be doing is I will be simply dividing these two equations. So 20 upon 60 will be equal to 1 by 3, and this will be this R naught and R naught will get cancelled out, and I will be getting 1 plus 20 alpha divided by 1 plus 500 alpha. So from this equation, I will be getting 1 plus 500 alpha is equal to 3 plus 60 alpha. So from here, this to 440 alpha is equal to 2. So alpha will be equal to 2 upon 440, or it can be written as 1 divided by 220. So I will be just writing this value of alpha here, that is alpha is equal to 1 divided by 220. Now we have to find the temperature at which its resistance is 25 ohms. So I will be again using this equation, that is RT is equal to R naught 1 plus alpha T. That is, so 25 is equal to R naught 1 plus alpha T. Now here T is the temperature at which its resistance is 25 ohms. So this, now I have got, this is the third equation which I have got, and this is the first equation based on the first condition. This is the second equation based on the second condition, and this is the third equation based on the third condition. So from, let us say this is the equation number 3, this is the equation number 1, and this is the equation number 2. So from what I will be doing is, again I will be using the equation number 1 and 3 in order to find the value of T. So